Hello and welcome to the Tech Symposium presentation for the group SH Industries, and our product is the Preventerr. I'm Harshal Bhakta and I'm the team leader.
I'm Miriam Mafraz and I'm a circuit designer.
I'm Raul Cantu and I do the 3D CAD modeling.
And I'm Kenna Huey, the project manager. So the purpose of our project is actually to design an alarm system that notifies the workers of unsafe conditions. We chose this project due to the deaths that occur annually from roofing construction workers. And our project will use multiple sensors that determine the worker's position and uploads them to a database using Wi-Fi. And this database will be available to the supervisor, and it'll help make sure that the workers follow work protocol and OSHA protocol as well. So this is going to be our background slide. It shows the gear that the workers use every day during their jobs. And housing 1, which is going to be our master or gateway, is going to be attached to the lifeline, and housing number 2, which is the slave or tag, is going to be attached to a worker. And so the master, which is housing 1, will send a signal to housing 2, and housing 2 will then respond back to housing 1, and in housing 1 will collect the time that it takes the signal to travel back and forth between the two housings, and then use that to determine the distance between the two position tracking modules.
So one of the housings that we created is called the Gateway. It contains the Raspberry Pi, the RFID, the ultra-wideband, and a 3500 milliamp hour battery, and the buzzing. The overall function of this component is that it tracks the housing 2 as it alarms the user whether they are outside safe boundaries of a perimeter of 6 feet, as well as it alarms the user whether they are not attached to the lifeline. So this next component is called housing 2. It's also known as the tag, which contains the ultra-wideband and a 3000 milliamp battery. This product is being tracked by the position by housing 1, and also worn using Velcro straps so it can be easily detached and put on.
So one of the modules we're using in our product is ultra-wideband. What this technology does is it utilizes low power data communication, just like low power Bluetooth engines and Wi-Fi. It also provides higher channel bandwidth, so we can have more data and we can isolate the channels for each product. It also helps us potentially pair up to 12 modules to it, and it works when there's no direct line of sight between the transmitter and the receiver. It uses radio frequency for doing that kind of communication. The ranging accuracy is 10 centimeters because of the higher frequency, and the position is calculated using a time difference of single-sided two-way ranging is what we're using for data collection. The two ultra-wideband modules here can be used for the distance calculation between the devices. One is the gateway and the other one is the anchor, as spoken by Raul. And the clocks of each device is calibrated and synchronized with each other. Once a gateway transmits a signal, the polling interval starts, and the tag receives the signal, and they're on the same network, and it sends the signal back to the gateway, and that's how the difference between the time gives us the position calculation.
Okay, so as for the RFID and the buzzer, once data is collected from the ultra-wideband modules, the Python code will make the RFID work in conjunction with the buzzer as the alarm system of the device. The code will work as follows. So if the user is within 6 feet distance from the anchor point, which is the gateway, and is attached to the lifeline, the device will just keep gathering data. And then if the user is not attached to the lifeline but is still within 6 feet from the anchor point, the buzzer will beep once every 5 seconds. And if the user is detached from the lifeline and is outside the 6 feet boundary, the buzzer will beep continuously. And having the buzzer beep continuously will notify the user that he is not in a safe zone. in conclusion, the overall purpose of our devices is to ensure the safety of construction workers and roofs. And this happens by gathering position data and monitoring the safety of the workers. And this will also help companies in reducing liability costs.